Hi there, my name is Thiago Croce and I'm one of the application developers at OmniTier. Today I would like to go over how our MemStac solution can seamlessly work together with some of the more popular frameworks to improve application performance. As we have seen in other OmniTier presentations, MemStac is an in-memory processing solution that sits between the application and database layer, giving significant boosts to application performance. MemStac delivers the advantages of an in-memory solution while overcoming obstacles that face today's market solutions. It's a drop-in replacement for the widely used memcached in-memory caching solution. At its core, MemStac's vertically integrated solution provides the advantages of an in-memory solution and benefits beyond current market competitors. Solutions today are DRAM-based, which can provide the high performance but also come at higher cost, power, and limited scalability. MemStac can provide the same level of performance as today's solutions while maintaining a reduced TCO and lower power. And depending on the use cases, a denser MemStac cluster can provide higher application performance compared to a DRAM-only solution. Today, MemStac is compatible and has been tested with various application frameworks. The frameworks that I would like to focus on today are two very popular Java projects, Hibernate and Spring Caching. Hibernate is very widely used for mapping object-oriented domain models to relational databases, allowing developers to build simple code that is database agnostic. Spring is a project that provides abstractions for a variety of different topics, such as dependency injection, web application development, object relational mapping, and caching. Hibernate performs caching at two levels. Level 1 is very basic out-of-the-box caching that is kept within the scope of a single Hibernate session. Level 2 caching is more robust and allows you to maintain serialized entity objects cached across multiple Hibernate sessions. Similarly, Spring Caching uses a combination of annotations and configuration to give you complete control over your specific cache workflow. Both projects are flexible in what application to use as the actual backend cache through custom-built plugins. Hibernate Level 2 caching can connect to MemStac through a plugin called Hibernate L2 Memcached, while Spring Caching can connect to MemStac through a plugin called Simple Spring Memcached. The level of configuration and code changes required to set up MemStac as the backend cache for either framework will vary depending on the current state of your application. If your application is already set up to use either Hibernate Level 2 caching or Spring Caching, but is just using a different backend cache than Memcached or MemStac, you will very likely not need to make any code changes at all. You just need to update some configuration files. If your application is not currently doing any caching, however, you will need a combination of configuration and code changes to take full advantage. So let's start with Spring Caching. So just a quick disclaimer here, the configuration and code changes I will be showing in my examples are specific to Spring version 3.1 and later. The Simple Spring Memcached plugin documentation, though, does explain how to configure your application if you're using an earlier Spring version. Okay, so since MemStac is a drop-in replacement for Memcached, the entire configuration for using MemStac is the same as if you were configuring the system to use Memcached, which boils down to defining two Java beans, a cache manager and a cache factory. The cache manager bean defines the cache settings at the level of the Simple Spring Memcached plugin. So you will want to take a look at the plugin's documentation to make sure that these settings are appropriate for your environment. For example, the property that I have listed here sets the cache entries to never expire, which may not actually be what you want. The cache factory bean defines the client factory client class that the plugin will use to communicate with the backend cache. I am using the Spy Memcached client for my example, but there are other client libraries that you may choose to use instead. These libraries, as well as the parameters that they require, are also documented on the plugin's documentation. If you already have your Spring Caching set up and you're just using something other than MemStac as the backend cache, making these configuration changes should be all you need to do on the application side. If not, you will need to do some additional changes to the application code itself to define your actual cache workflow. Spring caching is controlled by annotating methods. For example, by using the cacheable annotation, you're flagging a method as cacheable. The first time that the method is invocated, it will execute normally and the results will be cached. In subsequent calls to the method with the same parameters, the results are grabbed from cache instead of re-executing the method. You can choose any method as long as it contains at least one parameter and return value to cache, but you will really see the most benefit from a method with a relatively slow execution time, such as one that executes JDBC calls. The Spring Caching project documentation has really good details on all the available annotations and when to use them, so please be sure to take a look as you're planning your overall cache strategy. Alright, so moving on to Hibernate. In your Hibernate configuration file, you want to turn on level 2 caching and set the cache region factory class to the memcached region factory class. These two configuration items are what connect Hibernate to the cache provider. The next several configuration items configure the Hibernate L2 memcached plugins integration with the cache itself and will be different from one environment to the next. So you will want to take a look at the plugins documentation to make sure that things here are configured correctly for your specific environment. So again, if you already have your Hibernate level 2 caching set up previously and you're just using something other than MemStac as a backend cache, making these configuration changes should be all you need to do on the application side. Otherwise, you'll need some code changes. By using the cache annotation, you are flagging an entity class as something you would like to cache. The first time that a database entry represented by this entity class is grabbed from the Hibernate session, we query the database and place the serialized entity object in the cache. Subsequent requests to grab the same entry will then grab from the cache instead. In this example, I'm using the non-strict read-write cache strategy, which allows me to read and update objects of this type, but does not actually lock the cache during an update. This does present a chance of stale data being presented to the user, which I chose to be okay for this particular example. There are other cache concurrency strategy options available, such as read-write, which does lock the cache during a cacheable object update. The Hibernate Level 2 cache documentation contains real good information on these options and when they should be used, so please make sure to check that out as you're planning your overall cache strategy. Okay, so let's look at some performance comparisons with these frameworks. We collected some data through a simple web application workflow and found that using no Spring cache at all produced a significantly lower number of page requests per second. We also found that it didn't take much to bottleneck the database, where splitting the load across more web servers actually didn't help the performance. The two Spring cache enabled runs, one using memcached and one using MemStac, produced very comparable results, both in terms of page requests per second and average latency. So in a more realistic scenario where the data set is actually too large to cache everything, however, is where you'd really see the significant benefits of using MemStac due to its much higher capacity. The overall system performance would be significantly higher for MemStac in this case, as we mentioned earlier in the presentation. There's a similar story using Hibernate with a slightly different web application workflow. We found that using no Hibernate Level 2 cache at all produced a significantly lower number of page requests per second. The two Hibernate Level 2 cache enabled runs, one using memcached and one using MemStac, again produced very comparable results. And again, in a more realistic scenario where the data set is too large to cache everything is where you'd really see the significant benefit of using MemStac and its higher capacity. For deployment purposes, MemStac is available as an appliance server, which is optimized for performance. For cloud instances, MemStac is available as pre-configured images compatible with standard containers for deployment. Compatibility has already been tested with AWS, Google Cloud Platform, and IBM SoftLayer. Being memcached compliant, MemStac requires no changes to existing applications. MemStac is a solution that provides significant improvement to application performance. Higher application performance can lead to better user experience and ultimately higher revenue. MemStac overcomes obstacles that face today's current in-memory solutions and will continue to grow and evolve to address various markets such as IoT and analytics. This video only covered MemStac's value proposition when used in conjunction with application frameworks caching capabilities, so please check out our other videos on our website for more MemStac use cases. Thank you so much for listening.